Here's a final topic for this section, finding the x and y intercepts of a graph. Now let me explain what they are first on a graph. So let's say we have this graph. I'm just going to make it up here. Let's say we have this graph, okay? The x-intercept, it's the point where the graph intersect with the x-axis. So here's the x-axis. The graph, this orange graph here, intersects with the x-axis at this point and this point. So therefore, those two are the x-intercepts. And then the y-intercept is the point where the graph intersect with the y-axis. So this orange graph here intersect with the y-axis at this point. So right here, this is the y-intercept. These two are the x-intercept. So to find the x and y intercepts algebraically, like without any graph, let's say we don't have any graph, then here's what we do. To find the x-intercept, you let y be 0. In our case, y could be represented with f of x, so really we're letting f of x be 0. And then you solve for x. And when you find the y-intercept, we're going to let x be 0, then solve for y. So let's apply that into these problems. We're going to try to find the x-intercept and y-intercept for each of these. So x-intercept first, we're going to let f of x be 0. So f of x is equal to negative 5x plus 1. We let it be 0. Then you solve for x. So you will subtract 1 from both sides first, get negative 1 there, and divide both sides by negative 5. Then you get x is equal to negative 1 divided by negative 5. So that's going to be 1 over 5. Now, we always want to write the x and y-intercept as ordered pairs because they are points. So to write this as an ordered pair, you're going to write 1, 5 for x, and then for y, remember y is 0, so always write 0 as the coordinate for any x-intercept. Okay, and then the second example here, we have g of x is equal to negative 2. Oh, wait, back up a little bit. We're going to find the y-intercept first. So let me erase this graph. So to find the y-intercept, okay, this time we're going to let x be 0. So we're looking at f of 0. See, x is 0. So you plug 0 in for x. So negative 5 times 0 plus 1. That's going to be, this is 0. And so we'll just get 1. And to write the y-intercept as an order pair, we're going to write, remember x is 0. We let it be 0. And then y-intercept is whatever value that you found here. Okay, so let's look at the second example. Here we have g of x is equal to negative 2, which is a constant function in this case. So x-intercept. Remember we let y be 0. So g of x, in this case g of x is equal to negative 2 equals 0. But look, negative 2 can't be 0. That's not possible. So what does that tell us? This one has no x-intercept. Okay, no x-intercept. Now we're going to try to find the y-intercept. So the y-intercept, let x be 0. Remember, it's mentioned up here. But we don't see any x. So what do? Now, I'm going to rewrite this function here, actually. Remember, this is a constant function. Technically, it is a linear function, just a special case of a linear function. So is there any way that we could write this in the form mx plus b? Yes, we can. We can write 0x minus 2. Now, this still gives you negative 2 because 0 times x is just going to be 0. But you can see that m, which is a slope, would be 0 here. Okay, so by writing it this way, I can see the x. Now I try to find the y-intercept. So what do? So g of 0, x is 0, which is 0 times 0. I'm just plugging 0 in x for that expression, and then minus 2. So 0 times 0, just 0. And at the end, you just get negative 2. So then the y-intercept would be the point 0, negative 2. Now, if you're still not convinced, we can look at the graph of this function. Okay, we know that it is a constant function, which means that the graph would be a horizontal line. Where is that line? So negative 2, y is equal to negative 2, that's down here. It's going to be this line right here. Now remember, the x-intercept is the point where this orange graph or the graph of a function intersect with the x-axis. But look at this orange line here. It is parallel to the x-axis, which means it can never touch or intersect the x-axis. So therefore, it is consistent with what we said about no x-intercept. Okay, because it never touches, never crosses, never intersects with the x-axis. Now, is the y-intercept going to be 0, negative 2? Well, yes, because if you look at this orange graph, it cuts or it intersects with the y-axis at this point. And what is that point? That point is 0, negative 2. Remember, the equation is y equals negative 2, so the value would be negative 2 there. So as you can see that the y-intercept is a point 0, negative 2. That's where the graph intersects with the y-axis. Okay, our third example is actually very similar to the first one. I just want to show you again. So to find the x-intercept, we would let y be 0 or h of x be 0, which means negative 1/2 x minus 3 is equal to 0. So feel free to pause the video, give this problem a try, and then come back and see the answer. And solve, we're going to add 3 to both sides. So we have 3 here. And then to cancel that denominator, I could multiply both sides by 2. Multiply both sides by 2, so I have negative x is equal to 6. And then finally, we divide both sides by negative 1. You get x is equal to negative 6. So the x-intercept would be the point negative 6, 0. And then the y-intercept, let x be 0. So we're looking at h of 0. That's negative 1/2 times 0 minus 3. Well, negative 1/2 times 0 just going to be 0. So at the end, we get negative 3 left. So the y-intercept would be the point 0, negative 3. If I were to graph this last function right here, I could use the x and y-intercept to do that. So all we have to do is just plot those 2 points, negative 6, 0, and 0, negative 3. So negative 6. Negative 6, 0 would be this point right here. And then 0, negative 3, that means you would just move down 3. And that would be this point right here. And then all we have to do is just connect to those 2 points, and that will give us the graph of the function negative 1/2 x minus 3.